Now, the topic that we are about to treat now is indices. And when we say indices, it simply means index. Don't forget, in your GSS 1, GSS 2, everything you have done, they are the ones that you are going to be encountering when you want to write your GSS 3 examination. So that's why you need to know that whatever you are being taught now, they are the things that you need to understand, and you need to be rest assured that you are going to understand every thing that we are going to be discussing here. And when I'm talking about that, last week we treated standard form, and I have taught you standard form of a number that is greater than 1 and the one that is lesser than 1. That was the last thing we did. Today now, there are some aspects of standard form that you can actually solve using what is called indices. Index, you have a number or an alphabet raised to the power of another number. You need to understand the fact that this alphabet that is carrying a number is called base, while this one is called index. So, index or power. And you see all these things that we are talking about. Any calculation that you need to do will be based on what is called index and base. Okay, take for instance, you have 3 times 3 times 3. We have 3 in 3 places, isn't it? Yes. This is going to be 3 raised to the power of 3. You see these 3 that we wrote here, and the one that is the power. This 3 that is here is the base, while this 3 that is up is the power. Do you understand now? So, I can have 2 times 2 times 2 times 3 times 3 times 4 times 4. Then times 4 times 4. If I am to write this thing in index form, what it means is that I have to count the number of 2, the number of 3, the number of 4 that are there. That is why I'm going to have 2, 1, 2, 3. 2 raised to the power of 3 multiplied by 3 raised to the power of 2 multiplied by 4 raised to the power of 1, 2, 3, 4. What I have written here, they are called index. I'm writing using index or indices. Let's now go to this. You are in GSS. According to your curriculum, I need to teach you what is called laws of indices. But I'm only going to teach you 2. These 2 that I'm going to teach you, they are the ones that you need now. Later in life, when you get to your SS1, SS2, SS3, you are going to be learning further laws on indices. Now, the first law says that when you have 2 alphabets or number with the same basis and different power, the law states that when you want to write your answer, you pick one of these, then this multiplication turns to plus, and that is why you are going to have, let's say this one is x and this one is y. You are now going to have x plus y. This is how your answer will look like. I hope you understood. So, let's now move on. Let me give you examples of this. You know, I said indices, index. Let me give you an example on this. Examples. Number 1. Let's assume I have x raised to power 5 multiplied by x raised to power 6. Instead of me writing x times x times x in 5 places or x times x times in 6 places, I don't need to disturb myself. The only thing I need to do is to say, pick one of the base, which is x, I have 5 here. You say 5 plus 6. So your answer is going to be x raised to power 5 plus 6 is 11. X raised to power 11. I hope you understood. Now, let me give you another one. Let's assume we have 10 raised to power 10 times 10 raised to power 5. Actually, this one becomes 10 raised to power 10 plus 5, which becomes 10 raised to power 15. Another example. You see, these examples I'm giving to you follows the law. Look at this now. Let's assume we have y raised to power 10 times y. When you have a single number or single alphabet without any power up, the power that is going to be on top of it is going to be 1. So, I said y raised to power 10 times y raised to power nothing. Is that not so? So this becomes y raised to power 10 plus 1, because this y is standing alone. So it's going to raise to the power of 1. Our answer is now going to be y raised to power 11. You see, these 3 examples follows this law. Now, look at another question. Let's assume that you have 5x squared times 4x raised to power 5. 5x squared times 4x raised to power 5. These two, if you look at it, you will notice that it does not come with a single alphabet or a single number. It actually has numbers at the back of each of those alphabets that we have there. And if you look at it, you need to know that this thing is going to follow rule if you follow appropriate ways of solving it. Look at this now. You have 5 here, you have 4 here, you pick the numbers first. You are going to have 5 times 4. Now, you have your x here, you have your x here. You pick the x times x raised to power then 2 plus 5. So, this x and this x follow the laws. But because we don't have this number before, we have to multiply the number first. And what you are going to have is that 5 times 4 is 20. Then x raised to power 7. So this we have actually deviated from this law a little bit. Look at this one too. Let's assume I have 3x raised to power 5 times 4x raised to power 6. This is what I actually have. So you are going to say this equals 3 times 4. Then put the x here, raised to power 5 plus 6. And this is going to be 12x raised to power 11. I hope you understood what I'm trying to explain here. So this is the first law. Now, moving to the second. We are done with the first law, which is multiplicative law. The second law is division law. What do I call the law? Division law. So, this law states that when you have a number or alphabet of the same basis, they have the same base. They have the same base, but division sign is at the middle, and they have different power. The law says that these division signs change to minus. This division sign change to what? Minus. Do you get now? Division sign change to minus. And when you have division sign as minus, your answer is going to be like this: x minus y. So when you have it that way, the next thing that you are going to do is that the next thing you are going to do now Let's see some examples that can follow the procedure. Let's see some examples that can follow the procedure. And the procedure is this. See this one. We have a raised to power 5 divided by a raised to power 2. But they are having the same basis. The next thing you need to do is to say, pick one of the base, then the number that is up is 5 and 2. But you have a division sign here, you have to have 5 minus 2. At the long run, you have a raised to power 3. This example follows the law squarely. Look at this. You have a raised to power 7. Okay, don't let us use a this time around. Let's use x raised to power 7 divided by x. I told you earlier that when a number is standing single-handedly or an alphabet standing alone, it is raised to the power of 1. It is raised to the power of 1. So you have x raised to power 7 minus 1, which is x raised to power 6. Look at another example. I have 9p raised to power 4 divided by, let's say, 3p raised to power 2. Now, the law will still hold, but what will happen here is that those numbers we have at the back of each alphabet will be taken separately, as the way we have done the first one. We are going to say 9 divided by 3, then we put our p here, our 4 minus 2. We are going to have 3p squared, and that is going to be the answer. Look at this. Sometimes the examiner might want to check whether you actually know what you are doing. What you are going to have here is to say, okay, let's assume we have 9 times 10 raised to power 6 divided by 3 times 10 raised to power 3. If you look at this, it looks somehow cumbersome to you, but it is never. Looking at this, you do it the same way you have done this. You are going to have 9 divided by 3. Then you have your 10 here, you say times 10 raised to power 6 minus 3. Because of this division that you have here, you have a division line here. Because of this division, that is why you are having the minus up. So this becomes, our answer is going to be what? 3 times 10 raised to power 3. That is all. So that is another law that you need to know. But I think at the beginning of this class I said I wanted to treat 2 laws, but let me give you one more, because if you check your GSS 3 past questions, you are going to notice that question also comes out almost every year. I call it multiplicative law. Multiplicative law. And this one says that when you have a number inside the bracket here, or alphabet inside bracket, raised to any power, and you cover the alphabet, still raised to the power of another number. Let's say this one is x and this one is y. What you are going to have is to say a raised to power x times y, and this is a raised to power x y. This is a law, another law that you need to understand. So, having it like this, we are going to let's do some examples. Let's assume you have 2 raised to power 3, then you have maybe 4 outside the bracket. What you are going to have here is to say 2 raised to power 3 times 4, which is 2 raised to power 12. Sometimes you might have, let's say, 2 raised to power 1, then you have 5 outside. This is going to become 2 raised to power 5 automatically. And 2 raised to power 5, 2 in 5 places is 35. 32. Sorry. 2 times 2 times 2 times 2 times 2. That is going to give us 32. Do you understand? So, see another one. Let's assume that you have 5 raised to power minus 2, then raised to power 6. This becomes 5 raised to power minus 2 times 6. 5 raised to the power minus 2 times 6. And that is going to become 5 raised to the power minus 12. So with this, I think this is the first step, and this is where I'm going to stop for now. Thanks.